So in this particular video, we're going to cover the concept of classless interdomain routing, or CIDR. So classless interdomain routing. Now before we get into that, I want to give like a brief history of IP addressing and where classless interdomain routing actually came from and how it evolved. We started out in the 1960s, late 1960s, with the beginning of the internet. It was called ARPANET at the time, and it was really a network between 4 universities that were contracted with by the Department of Defense to develop computer networking for communication purposes. And those 4 universities, UC Santa Barbara, Stanford, UCLA, and the University of Utah. That was established in 1969. Well, at that point, we weren't really thinking about addressing. We just had these 4 different interconnected organizations that were communicating back and forth. But as this thing evolved, we realized, wow, we really need some type of addressing scheme that we can grow with, that's scalable. And so in the 1980s, we came up with what was called classful IP addressing. Well, classful IP addressing is illustrated in these charts right here. We gave it the name Class A, Class B, and Class C to kind of designate which range of addresses was which. And there were kind of hard boundaries at that point. With the Class A address, you can see that N there, right here. And that N stands for network, and that was the network portion of the address. And we'll get into the addressing here in a little bit. And the rest of these were actually able to be assigned to host values. So computers, printers, what have you. And then we had Class B addresses, and we had 2 network portions. Now, as I'm talking about this, I'm kind of assuming an understanding of IP addressing at a basic level. So we had 2 sections that were network address areas, and then 2 sections that were assigned to host addressing. Okay, so 2 sections of the address scheme. And what we realized as this evolved and kind of blew up and we started to develop internal networks and, in addition to the internet, we realized that we needed to be able to be more efficient. We needed to be able to use these address spaces more efficiently. Because if you look down here, a Class A address allows for 16,777,216 possible host addresses. Well, that's a lot of addresses. Most corporations don't come close to being that size. The internet has actually outgrown that, and we're moving towards IPv6 at this point. But at this time, in the 1980s, this was certainly a reasonable amount of addresses for us to work with. So when we realized that we needed to be able to be more efficient in these internal networks in particular, we developed the idea of classless subnetting, or classless interdomain routing. And basically with classless interdomain routing, we're looking at these boundaries and we're saying, you know what, forget that. We can manipulate these numbers in a way to be efficient and to just capture the number of hosts that we need for a particular network. So our goal of subnetting, and keep this in mind because people tend to complicate the process of subnetting, but the goal of subnetting truly is just to be efficient. I just want to capture the number of hosts that I need. So for example, if I have a department, we'll call it production, and that department has 308 users, and that could be printers, that could be PCs, that could be really any type of device, but it's got 308, we'll call them endpoints that we need to apply an IP address or an address to be able to communicate across our internal network. We've got research and development, or R&D, and in that particular department, we have maybe 75 addresses. And then we have an HR department, a human resources department. And let's say that's got 12 endpoints or end users that we need to assign IP addresses to. And let's say that we have an address assigned to us, an address space of 190.168.0.0. Well, this is a Class B address. So it's a Class B address. And that means that we have 65,536 addresses in that address space. Well, that's quite a bit more than all three of those networks combined, and we want to separate those networks anyway. So what we realize, and we're going to convert this into a binary value. I'll assume an understanding of basic IP addressing and working with binary values. If you have questions about that, there are a couple of other videos that you can look at that we've produced that would help you understand. But I'm just simply going to write out the fact that this is a 1, 0, 1, 0 dot 1, 0, 1, 0, 1, 0, 0 dot 0, 0, 0, 0. And that's a binary value for this address, the 190.168.0.0 address. Now, all we're really going to do is we're going to look at each one of these individual networks, and we're going to ask ourselves the question, how many hosts do I need to capture? How many hosts do I need to capture? And we are going to do a little bit of binary conversion here. We're going to say, okay, so 2 to the 9th, we'll say 2 to the 9th, 2 to the 8th, 2 to the 10th, 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1, and 2 to the 0. And we're going to look at all these bits. And I went up to 10 because 2 to the 10th equals 1,024. Okay? And I want to use that just for illustration purposes. 2 to the 9th equals half of that, which is 512. 2 to the 8th is 256. 128, 64, 32, 16, 8, 4, 2, and 1. And if we back up here a second, we realize we only need 308 host bits. 308 host bits. And that falls right here in this 512 range. Now that's too large, that's too many, but that's okay. We want to leave room for growth anyway because we're trying to be efficient. So there's 512 hosts there. 256 is too small. And so what I realize is that bit stops right there. So I'm only going to be using these bits for hosts. Those are the only bits I need. I don't need all 16 of these that were out there. So what I realize now is that I need 168.0.0 is that I can indicate that demarcation point by capturing the number of bits that I'm going to use for networks. So everything to the left of that bit is the 23 bits, or the /23, or the CIDR, the Classless Interdomain Routing denotation. That's how I denote that. And so my first network address is going to be exactly that, 190.168.0.0/23. Now I can only use a certain range of addresses. I have to leave off the first and the last address. The first and the last address. The first address is my network ID. So that value right there is going to represent my network identification. My first usable address is going to be 190.168.0.1. My last usable address is going to be 190.168.1.254. And my broadcast address, which I also have to reserve, is going to be 190.168.1.255. Now notice that what happened here is that in this first octet, which is represented by these 8 bits, this rolled over twice. So it rolled over, it went up to 255, and this became 1. And it went clear up to 255 again, capturing those 512 bits that I referred to initially. What that tells me is that my very next address is going to be 190.168.2.0. Now this is where I'm going to start with my very next subnet, And if we look back at that grouping of departments that we're trying to subnet out, research and development is my next one. And I have 75 hosts there. 75 hosts. So before I jump back down to the screen, I look at my binary format here, and I realize, well, 64 is too small, but 128 is going to capture those 75. So I'm going to stop right here. I'm going to stop right there at that bit right there. And that bit is the 25th bit. So my next address will be /25. And that's going to be my next network address. And that's going to be for my R&D department. And I need 75 hosts. And just to illustrate this, take it a step further, I've got those 7 hosts. 2 to the 7th equals the 128, which captures that. My first usable address is going to be 190.168.2.1. My last usable is going to be 190.168.2.126. My broadcast address is going to be 190.168.2.127. And my next address begins right here. So my next network address, which is going to be for the HR department, which has 12 people in it. So I only need 12 end users, 12 endpoints. It's going to be 190.168.2.128. Now, the question is, based on the number of hosts that I need, where do I stop? Well, 2 to the third is not enough. That only gives me 8. I need 12, so it's going to be 2 to the fourth. 2 to the fourth. So I'm going to stop right there, and I'm going to use those 5 bits, right? That's going to give me a /28, 2 to the fourth equals 16. So it's going to give me that 12 hosts that I need. My first usable, 190.168.2.129. My last usable, 190.168.2.142. My broadcast, 190.168.2.143. Now, if I needed another network, my next network begins at 190.168.2.144. So we have just subnetted out these various departments. We have efficiently used the number of hosts and captured the number of hosts that we need for these departments. We've got a little bit of room to move, a little bit of room to scale up if we need to. But again, our purpose here as administrators, as network administrators, is to simply be as efficient as possible, to use the address space as efficiently as possible. And that was the reason that classless interdomain routing was initially developed. Because as we look back, the classful system was a very, very inefficient use of this address space. Hopefully this has been helpful. We'll guide you in understanding classless interdomain routing and the process of subnetting.